Alright, GeoTrig Lesson 10, Note Outline. The first thing that we're going to talk about today is equations of a line, so line equations. Now there's a couple things that we should probably talk about here is horizontal lines, vertical lines, and what is slope. Horizontal lines is a line with a slope of 0. And remember, horizontal, if I was going to draw a graph, would look like, I'm going to change to a darker color. If I had my axes, my x and y axes, a horizontal line would be a line that's horizontal with arrows on both sides because it goes on forever. And remember that horizontal lines always follow in the format of y equals, let's say b. B, because we had a slope-intercept form. B is the y-intercept. The next one is a vertical line. Vertical lines is a line, so it's a line with an undefined slope. That's not a T, that's not stope. I'll pick that up. Slope. And I'll change colors to red here on the same graph. The red one is a vertical line, and we generally say that's x equals, I'm going to say a for now, where a is some x value that it crosses on the x-axis. That's a vertical line. So those are two special lines. It's kind of nice with those. Who remembers what slope is? Slope is rise over run. That's the simplistic way that we've talked about it or learned about it, was just rise over run. Now we also learned another way to find slope, because rise over run works really well if I'm given a graph and I can count up and over, then I can get my numbers. But if I'm not given a graph, maybe I'm just given a set of points, yes, you can graph it so you can make your triangle to find it. Or you can use a slope formula. So who knows a slope formula? It is, everyone, y2 minus y1 over x2 minus x1. Great job, everyone. So we have two different ways to find slope. And I put a little star there. It says that any non-vertical line has a slope and a y-intercept. Notice that the vertical line is straight up and down. It's undefined slope. And it'll never touch the y-axis because it's parallel to the y-axis. So it'll never touch. But any other line, no matter what the slope is and what the y-intercept is, or y-intercept, they'll always touch both axes. So you have to be careful on that, because it will have a tilt to it. Parallel lines. Obviously we all know what parallel lines look like. Parallel lines look like this. And the special thing about parallel lines is they never meet, right? They never meet. And the cool thing about it, they have same slopes. The slopes are the same. So I told you the slope of line 1 was 4, then the slope of line 2 is 4 as well. So move on to perpendicular lines. Perpendicular lines, we've been talking about perpendicular lines in our proofs, and we know that perpendicular lines meet at right angles, so they definitely do not have the same slope. They actually have opposite. Sorry, we want to say opposite. When I mean opposite, I mean sign. Opposite reciprocal slopes. And what I mean by that is if the first slope is m, then the other one, or the next line, would be negative 1 over m, or the opposite. I don't want to necessarily say, I don't like to say negative, because if I use negative, people might think that if it's already negative, it stays negative. but you have to remember it's a negative of a negative, so it turns it positive. So we like to say opposite. So the opposite reciprocal of the slopes. So if I said 2, then it would be a negative 1/2. So now we're going to move on to types of slopes here before we move on to some equations. Positive slope. Adam, please show me positive slope with your arms, please. Awesome. Yes, you are correct. Going from left to right, it rises. So therefore, that's a positive slope. Alex, you're next. What's a negative slope look like? No, other way, Alex. Okay? Okay, right. Now we got it. So, from left to right, it looks like you're falling. And so, Ben, give me a zero slope. Right, zero slope is horizontal line. So that's familiar. So, those are the three types of slopes. You're going uphill, you're going in a positive direction, downhill is negative, and zero is going straight across. Those are the three slopes. I shouldn't have to explain too much of those. We've dealt with those quite often, or quite a bit in the last couple of years. Slope-intercept form. Moving on to slope-intercept form. This is the one that everybody likes. And that's y equals mx plus b, where m is the slope and b is the y-intercept. And it makes it a lot easier to graph when we have a slope and intercept, because I can plot the y-intercept and move slope, rise over run. And we'll do that in a second here. The next one is point slope. John, tell me point slope formula. I'll give you a couple seconds here. It's close. Does everybody agree? Disagree? Okay, show of hands. Who agrees with John? Who disagrees? Who's not voting? Guys, you just voted. You just raised your hand. Anyways, point slope form, remember, is y minus y1 equals m times x minus x1. And that is point slope form, where m is still your slope, but this time your point x1, y1 is the point that you're given. So you'll have a slope and a point where you put in for x1, y1. So we're going to put these to use now. Write an equation with the given information. We're given 2 points. 2 points forms a line. And when I do this, I always put all my lines in slope-intercept form. It makes it a lot easier to compare lines, talking about their steepness, aka slope, and where their y-intercept is. So since I have these 2 points, there's 2 options I can go with. You can go and graph these, and I'll do that. So here's the graph. So the first option is to take our points and form a right triangle, where obviously this part that's connecting the 2 dots straight is a line, but if I can count those sides, I can basically find my rise and my run. So 1, 2, 3, 4, 5, 6, 7, 7, and 1, 2, 3, 4, 5, 6, 6. And now remember that I'm going down, so that you'd have to say that's a negative 6. So my rise over my run is negative 6 over 7. That's one way to find the slope. The other way is to use the slope formula. We can do that at different times. Just make sure that you name one of the points, point 1, point 2, and then therefore plug it in. So if I go with negative 6/7, I'm going to use the point slope formula. So y equals y minus y1 equals m times x minus x1. I use point slope because that I don't need to solve for b directly by plugging in more values. They're all going to be here, and then just solve for y. So y minus, and we got to pick a point. So let's go with the second point. So I'm going to subtract a negative 3 equals negative 6/7 x minus 4. Now granted, these are not always going to be nice numbers, but I think we can all assume that if you subtract a negative, you are going to add. And I have to distribute. So y plus 3 is equal to negative 6/7 x plus 6 times negative makes a positive, and 6 times 4 is 24/7. And of course, I think we all should agree that you're going to subtract 3 from both sides. And so here's our problem. I need to get that to be the same denominator of 7 because it's over 1. And so what's the common denominator between 1 and 7? It's 7. So I'm going to multiply the top and bottom by 7. So it's a negative 21/7. And 24 minus 21 is 3. So it's plus 3/7. And there's your line equation, or your equation of the line. So we're moving on to the second problem here. Now there is a point. First thing that we're going to want to do is take the line that we're supposed to be perpendicular to. Remember, perpendicular is opposite reciprocal slopes. I need to find the slope of that line. So to find the slope of that line, I need to change that. And so I'm going to solve it for y. So I'm going to subtract 4x from both sides. So 3y equals negative 4x plus 2. And then divide both sides by 3. So I end up with y equals negative 4/3 x plus 2/3. Now the cool thing about this is I can ignore everything about this equation except for that slope. And so I'm going to take the slope here. Remember, slope is in front of x. It does not include x. So our old slope is m equals negative 4/3. That's our old slope. I need a new slope. And my new slope is going to be m equals the opposite, so now we're positive, and the reciprocal. So we're going to flip it. So 3/4. And so I'm going to use m equals 3/4 and that point to find the line equation. And so I will do that quickly, and so we can figure that out. Again, use y minus y1 equals m times x minus x1, point slope form, and start filling it in. Y minus 5 this time because y is positive 5 equals 3/4 times x plus 5 because you're subtracting a negative 5. I'm going to do some of this stuff in our head nowadays to make it go a lot quicker. So y minus 5 is equal to, as I distribute, 3/4 x plus 15/4. I add 5 to both sides. I need to have a common denominator because that's really over 1. I am needed it to be a 4, so it's 4 and 4. So I end up with 20/4. And so what's 15 plus 20? 15 plus 20 is 35. So 3/4 x plus 35/4 is your solution. So on this one slide here, you're going to be given a graph. Give me the line equation. So I'm hoping that you guys see the blue line. The blue line is a horizontal line. And all horizontal lines are, if you remember back to our notes, should be a y equals. And it's y equals where it crosses the y-axis. And so it crosses the y-axis at 2. There you go. Those are easy. Horizontal and vertical lines are very easy to do. Now, when we talk about the red line, it actually has a slope, right? And has a y-intercept. Hopefully you can see that there. And it looks like it crosses at about 7. So there's our y-intercept. Now the next thing is, we could say, oh, way down here, that's a negative 3, okay? And so we got to find the slope of this. And if I notice that our intercepts actually turn out to be quite nice, I'm actually able to make that triangle or count over, and so I can do my rise over my run. Well, we know that we're on crossing at the y-axis, or the x-axis here, and so we're at the 0 on the x-axis, and so if I had to go up to that y-intercept, it would have to be 7. So we know my rise is 7, my run, and now, since we have these nice intercepts, and we're able to find that the rise is 7, the run is -3, we know that our slope of the red line is 7/3, or 7 over -3. And we have a y-intercept of 7, so it's y equals -7/3 x plus 7. Now we could have also used the point -3, 0, or 0, 7 with the slope of -7/3, and use point slope, solve the equation. So that's enough about lines. Let's talk about rational denominators, or rationalizing denominators. So remember that a rational number is anything that can be written as a ratio or a fraction. Basically, repeating decimals can be, terminating decimals, etc. So let's do 1/3 is the same thing as 0.3 repeat. Also something like 0.125, which actually can turn into 1/8. So those are all things that are rational numbers. Irrational numbers are basically the opposite. Non-repeating decimal. Can't be written as a fraction or a non-terminating decimal. And so pi is a very good example. We know it is 3.14, but it does continue on and on and on and on. There's something called e, which is 2.713, and so on and so on and so on. Those never end, so dots on the end of those. So a complex number, those are involving I, those are not considered rational. Why? Because what is a complex number? What is I? I equals the square root of -1. It's a square root, so therefore it's not going to be a rational number. And so we also need to remember that the square root of 5 times the square root of 5 is equal to 5. The square root of -1 is I, and I squared is -1. Those are all things that we've talked about in this year alone, so that's something that we should remember. So the process of converting the denominator to a rational number is called rationalizing the denominator. So our goal here is, with this problem, we got 5 over the square root of 2. I don't like square roots on the bottom of fractions in the denominator. And so we go back to this idea that we did over here, and I was able to say, hey, square root of 5 times square root of 5 is 5. And so I'll come over here and say, hey, how can I change using multiplication, because I can only multiply to the top and to the bottom of a fraction and not change it as long as it's the same number. What do I have to multiply by something by square root of 2 so that it goes away and becomes some nice number? And hopefully you're saying, hey, that's square root of 2. But what I do to the bottom, I have to do to the top. And so you end up with 5 square root of 2, because I can't put those together all over. Square root of 2 times square root of 2 is 2. And that's how easy they can be. They're easy like that. Now, going to the bottom one, it looks a little scarier. I still have just a square root of 3 on the bottom, but I have a binomial, 2 terms on top. Doesn't change anything. We still have to multiply the bottom by square root of 3, so we're going to multiply the top by square root of 3. Square root of 3 times square root of 3 is 3. That's fine. But we have to realize that I have a binomial on top with a monomial on the outside, and therefore I'm going to have to distribute. 2 times square root of 3 is separated, and then it's minus square root of 3 times square root of 3 is 3. You will leave it like so, because the denominator has been rationalized. You're good to go. Moving on to problem 3, I get 6 over I. And 6 over I, remember, I is just a square root of -1. Again, I don't like square roots. And so to get rid of an I, I'm going to multiply it by I to get I squared, which is right, -1. But what I do to the bottom, I need to do to the top. And do, so it becomes 6I over I squared. And 6I over, because I squared becomes -1. It's gone. And the answer is -6I. So working with I is very simple. It's the exact same thing as working with square roots. Now, moving on to number 4, it looks very scary. I have 5 minus the square root of 2 all over 3 plus the square root of 2. Now this one, I think we all should say, hey, to get rid of a square root of 2, I multiply by square root of 2. Now don't write this down yet. Now if I did square root of 2 over square root of 2, which is 1, it's doable, and I distribute, now remember the top doesn't matter. The top can have square roots, it can have radicals, those things. The bottom's the important one. I would eventually have to distribute. I think everybody can agree that when I go to distribute the square root of 2 times square root of 2, it becomes a 2. But I'm going to have to distribute all the way over to this 3, and I end up with 3 square root of 2 plus 2. What happens is that I don't get rid of the square root of 2. I just move it over. So that's not going to be a good option. I do not want to multiply it just by square root of 2. So I'm going to erase it, get rid of it. We don't need it. We're going to do something a little bit different. We're going to multiply by its conjugate. And the conjugate is the bottom. It's a 3 and a square root of 2, but it's the opposite sign in the middle. So it's 3 minus the square root of 2. And what again do you do to the bottom? You do to the top. Now the biggest problem or biggest thing about these ones is that you have to realize that it's a binomial times a binomial. So I'm going to go through and I'm going to put parentheses around everything, and then I'm going to have to use the 4-letter F word, and everyone, careful, FOIL. We FOIL this problem, okay? So 5 times 3 is 15. 5 times negative square root of 2 is negative 5 square root 2. Negative square root of 2 times 3 is a minus 3 square root 2. And a negative makes a positive, and square root of 2 times square root of 2 is 2. And I'll just do the same thing with the bottom. 3 times 3. And here's the thing, there's going to be something going on in the bottom. 3 times a negative square root of 2 is negative 3 square root 2. Not 3, but 2. Square root of 2 times 3 is a positive 3 square root 2. Remember to keep your terms in order. Constant, then radicals. It's going to make your life easier. And square root of 2 times a negative square root of 2 is a minus 2. And now I just got to gather like terms. Now I'm hoping everybody can see that, wait a minute, there was some reason why I had a positive, I multiplied by its conjugate. It allowed me to put a negative 3 square root of 2 and a positive 3 square root of 2, and they will cancel. And you're left with 3 minus 2, which is equal to 1. Gathering like terms, 15 plus 2 is 17. And negative 5 square root of 2 plus a negative 3 square root of 2, so negative 5 of them minus 3 of them is a negative 7 of them, and them are square root of 2's. If I'm just going to divide by 1, now a lot of times you can leave it here, but since 1 is just 1, I'm going to get rid of that completely and make our lives a little bit easier. And 17 minus 7 times the square root of 2. Moving on to problem number 5. Problem number 5, the exact same thing. This time it has an I. But remember, an I is a square root. So we are going to multiply by the conjugate of the denominator. But here it's saying this is a complex number. So therefore we're going to call it the complex conjugate. And that means what, guys? 2 minus I. 2 minus I. And again, they're binomials, so we multiply it that way. We have the FOIL. Now the top I don't have to FOIL. I just distribute. This is a 1 this time, so the answer on top is 2 minus I. Can't get much easier than that. And then again, the bottom, you have a positive, you have a negative. It's the difference of squares. The sum and difference, guys, is what's happening here, if you remember back to that. But you get 2 times 2, which is 4, minus 2I, plus 2I, minus I squared. Now be careful, you're using your order of operations. The top's not going to change. That is still 2 minus I. But the bottom, the middles will cancel again, positive 2I and a negative 2I. You get 4 minus I squared becomes a negative 1. And when you subtract a negative, you are adding, so you get 2 minus I all over 5. Now, I know I said last time you could probably leave it if there was just a number there, but this is a complex number. And remember, all complex numbers want to be in standard form, which is A plus BI. So, I need to separate. Let's separate it. Then becomes a 2/5 minus 1/5 I. So hopefully you guys are finding this to be pretty easy, simple, and doable as long as you remember to have to FOIL, you have to multiply, you're multiplying by conjugates. We don't like square roots on the bottom. Whoa. Let's take a look at number 6. Number 6, last problem what we're going to do, deals a little bit with that I stuff again. So on the bottom, you're going to have to deal with the complex conjugate, and the top has more than one I in it. So I'm going to clean it up. I'm not even going to go right away and try rationalizing anything. Number 1, I put things in standard form. That means your real number first, then your complex number. So automatically, I'm going to change the order around. Because if I don't change this order around, I'm more than likely going to mess up on the conjugate. So be careful on that. Change it up. Number 2, atop, I am going to go back to what we did a couple lessons ago. We can't forget these things. And I'm going to start to expand. I expand all of my I's because I'm going to circle my partners. Each one of those partner sets becomes a negative 1, remember? So this is negative 1, negative 1, negative 1. These two negative 1s become a positive 1, and I don't have to worry about it. But negative and negative makes a positive, so it becomes 2 plus I plus 2I all over 4 minus 2I. I plus 2I is 3I over 4 minus 2I. And of course, the last step here is we don't like i's in our denominator, so I'm going to multiply by the conjugate, and the conjugate is what? Jackson. I'll wait for you. Yep. It's 4 plus 2I. 4 plus 2I. And again, we have binomial times a binomial, so therefore you have to FOIL the top and the bottom here. You get 8 plus 4I plus 12I plus 6I squared all over 16 plus 8I minus 8I minus 4I squared. Be careful that you don't lose signs and you don't start connecting pieces before you multiply, because you're going to mess up. We can cancel here. Say that's negative 1. That's negative 1. These will cancel. I don't have to worry about those. 4 plus 12. Remember that this becomes a negative 6 then. So 8 minus 6 is 2 plus 16I all over 16 plus 4 is 20. So far, everything's divisible by 2. Oh, and the 8i and the negative 8i cancel out. So here it is. So I probably should reduce that. What's 2 divided by 20? Because I can do this. That's 1 over 10. Plus 16 divided by 20. I think I divide the top and bottom by 4. So I get 4i over 5. And maybe I'm going to back that up a little bit and make it 4/5 I. So 1/10 plus 4/5. Okay, homework can be found on the worksheet that is handed out to you today and also on Haiku. Have a great, fantastic weekend. Or day, actually.